Next, let's talk about a work coordinate system. A work coordinate system is how you connect the real world to the virtual world in Fusion. Let's start by making the real world look more like Fusion. Get a Blackmagic marker and find the face of your metal cube that was cut with a bandsaw. You'll be able to feel the ridges of the bandsaw if you slide your thumbnail across it. And write on this face the word top. Then flip the cube over and write the word bottom. Then pick any of the remaining 4 sides and write the word front. And from there, fill out the other 3 sides logically with back, right, and left. Then find the corner of the cube where the top, left, and back faces all intersect and put a little black dot there. This black dot marks the origin of the work coordinate system that you were going to use to do all of your work on this piece of metal. Now in Fusion, orbit the view until you're for sure looking at the word front in your compass, and notice the triad of XYZ axes sitting on the top center of your cube there. That XYZ triad is your work coordinate system, and I want you to move it to the back left top corner. And if your setup isn't already open, double-click on it to open your setup, and click on the Setup tab, and look at this panel right here for work coordinate systems. Make sure that the origin of your work coordinate system is going to be set to a stock box point, and then choose the box point by clicking on this box point button. When you do, you're going to see a host of clickable points show up on your stock, and the one you want to choose is the top left back point. When you do, just make sure that you're looking at the word front up in your compass and that you're choosing the one far away from the front, and that you're seeing the word top on your compass and you're clicking on the one on the top. And as you do, that you're imagining that what you're connecting is this virtual corner to the real corner on your metal that you marked with Magic Marker. Click OK on the setup panel to confirm that choice, and notice how the triad of XYZ axes stays there in your top back left corner. This is the origin of your work coordinate system. It is 0 on X, 0 on Y, and 0 on Z. Good, now let's do some work inside of this work coordinate system. Come on up to your toolpaths and click on the 2D drop-down and select Face. In the facing parameters, we're only going to do one thing. We're going to select a tool. So click the Select button and come to the Cloud library, select Makerspace Tools, and then select Tool 1, the 3/8 bullnose end mill. And if you're not seeing the Cloud library, just come over here to the silhouette and choose Preferences, Manufacturing Preferences, and check this box next to Enable Cloud Libraries and click OK. If you're a member of my class and you're still not seeing this, let me know. Otherwise, just do a bit of Google searching for how to make your own 3/8 bullnose end mill. Okay, having selected it, just confirm that you're seeing it here. Tool 1, the 3/8 end mill. And then look for a couple of parameters. The surface speed should be set to 500 feet per minute. The feet per tooth should be set to 2/1000ths of an inch per tooth. And the spindle should be spinning a little above 5,000 RPMs. In brief, surface speed is how fast the tooth of your tool is hurling itself through space. Feed per tooth is how big a bite that tooth is taking out of metal every time the tooth shows up. Spindle speed is how fast rotationally your tool is spinning around and around. Click OK to create this facing toolpath, and notice that it pops up over here under your setup, and notice that you get a visualization of the tool itself and the path that the tool is going to take from start to finish. Let's simulate this toolpath. Come over to your setup and right-click on the folder icon and choose Simulate. Then look down at the bottom at this green bar. This is a time bar, and I want you to click on the left-hand side and drag slowly across it. And watch the tool come down as it plunges through air, leads in towards your material, then starts cutting your material, leads out of your material, swoops a little further back, then starts cutting your material again, leading out and in, cutting, leading out and in, cutting, leading out and in, and cutting, until it has cut the entire top face of your stock off, revealing for the very first time the perfect model underneath it. Great, click Exit Simulation and orbit your view so that you're looking right across the top of your stock. And then simulate it again. Right-click on the folder, Simulate, and drag that time bar from left to right so that you can really see how the tool is coming down into your stock, back and forth, creating the top plane of your model. Click Exit Simulation, and congrats, you have made your first toolpath a facing toolpath, and you have simulated it. Next, we're going to talk about getting that data out of Fusion and over to the CNC mill.